Now, you know the basic structure of a clock, right? It has hour hand, minute hand, and the seconds hand, right? And basically, we will talk about the circular clock, okay? The 12-hour clock which we wear. So it has minute spaces, and the face of a clock, it is a circle, right? And it is a circle whose circumference is divided into 60 equal parts. They are called as minute spaces. So these are the basic things related to clocks, which I believe everyone knows, right? So let's come into the technical terms now. We take the reference point in that watch as 12 o'clock. Okay, reference point is 12 o'clock. So the hour hand, it comes back to its original position, to the reference point, exactly after 12 hours, right? The hour hand, it comes back to its original position after 12 hours, right? So in 12 hours, if you complete, guys, is there any problem? Okay, okay. Okay, so now my question for you is, let's assume that the reference point is 12 o'clock, okay? That position. So if the hour hand has made one complete revolution, okay? If the hour hand has made one complete revolution, okay? So it means I can say that the hour hand has completed 360 degrees, right? If the hour hand has made one complete revolution, then I can say that it has made 360 degrees, and it has made that 360 degrees in how many hours? It has made 360 degrees in 12 hours. And the speed of the hour hand is uniform, is constant during these 12 hours. So I can say that speed of an hour hand will be, like when you divide 360 by 12, you get 30 degrees. So I can say that the hour hand, it covers 30 degrees in every hour. So if the hour hand is pointing exactly at, let's say, 1 o'clock, and now later on the hour hand has moved to, let's say, it's pointing at exactly 2 o'clock now, okay? So initially it was pointing at 1 o'clock, now it is pointing at exactly 2 o'clock. So I can say that it has covered a total of 30 degrees. How 30 degrees? Because in 12 hours it completes 360 degrees. So in 1 hour it will cover 360 by 12, which is 30 degrees, right? 360 by 12, 30 degrees. Now it covers 30 degrees in 1 hour, and 1 hour is of 60 minutes. So if anything covers 30 degrees in 60 minutes, so in 1 minute it will cover 30 by 60, half degrees per minute. Okay, so this is what is written over here, that the speed of an hour hand is half degrees per minute. Okay, similarly if I talk about the minute hand, so you know that the minute hand, it comes back to the initial position after 60 minutes, right? It comes back to its initial position after 60 minutes. So now, since again the minute hand is also moving in a circular direction, so I can say that in 60 minutes it has covered 360 degrees. And if it has covered 360 degrees in 60 minutes, so in 1 minute it will cover 6 degrees. The minute hand will cover 6 degrees. Okay, so for example, let's say the hour hand, the minute hand, let's say the time was uh, 2:05. Let's say the time was 2:05. Okay, and then it became 2:06. So from 2:05 to 2:06, the minute hand has moved for exactly 1 minute. And if the minute has moved for exactly 1 minute, then it must have covered 6 degrees. Okay, so in that 1 minute, the minute hand would have covered 6 degrees, and the hour hand would have covered half degrees. Okay, now, guys, if you remember in time, speed and distance chapter, we discussed the concept of relative speed, right? And what was the concept? The concept said that if two objects are moving in the same direction, then the relative speed is the difference of the speeds. And if two objects are moving in opposite direction, then the relative speed is sum of the speeds, right? So in this case, you can see that uh, the hour hand and the minute hand, they both are moving objects, right? And they are moving in the same direction. So we can also calculate the relative speed out here. Yes, can we calculate the relative speed out here, guys? Can we use the concept of relative speed? We can use it, right? How can we use it? Because they both are moving objects. They started their movement from the same point, from the same position. Okay, the reference point is 12 o'clock, so they have started their movement from the same position. So if they have started their movement from the same position and they are also moving in the same direction, following the same path, then we can use the concept of relative speed. And in this case, since they are moving in the same direction, so the relative speed will be the difference of the speeds. So that will be 6 minus half, 5.5 degrees per minute. Okay. Now, uh, so comparing the speed of the minute hand and the hour hand, one can conclude that the minute hand is always faster than the hour hand by 5.5 degrees, or the hour hand is always slower than the minute hand by 5.5 degrees. Okay, so in this slide we got to know, we learned three data. First data is speed of an hour hand is half degrees per minute. Second is speed of a minute hand is 6 degrees per minute. And lastly, the relative speed is 5.5 degrees per minute. It means that the minute hand is 5.5 degrees faster than the hour hand. Okay. So here's a small basic question for you. Try to answer this question. It's a 10-second question, guys. Five people have answered now. Six. There are around 25, 26 people. At least 10 of you should answer this question. It's a very basic question, guys. Yes. The answer is option D, 180. Sandesh, the concept of relative speed, we actually discussed it in the topic time, speed and distance. It simply says that if two objects are moving in the same direction, so the relative speed is the difference of the speeds. And if two objects are moving in opposite direction, so the relative speed is sum of the speeds. Okay, this is the simple concept. Okay, so guys, in this particular case, the R hand initially it was pointing at 8 o'clock and then it was pointing at 2 o'clock. So it's a period of exactly 6 hours. So the question is asking us that in 6 hours, what is the degrees rotated by, what is the, like by how many degrees has the R hand rotated, right? So now we know that in 12 hours, it covers 360 degrees. So in 6 hours, it must have covered 180 degrees. Okay. Similarly, next question for you. Next question, guys. So this was the first slide, Sandesh. Simple understanding the structure. What are minute spaces? What is hour hand? What is minute hand? Second slide is what we were discussing about. The speed of the hour hand is half degrees per minute. Speed of the minute hand is 6 degrees per minute. And the relative speed is 6 minus half, 5.5 degrees per minute. These two were the slides which we have discussed till now. Okay. Okay, so guys, what is your answer for this question? What is your answer for this question? Only two responses till now. What happened? 3, 4 responses. Okay, so for those who are only 4 responses till now, what happened? It's very simple. Question is not clear. Okay, see, it's the time is 5:10. Okay, by 5 minutes past 10 minutes, 5:10, 5:10 हो रहा है. So you need to, and the clock has started at noon. So the clock has started at 12 p.m. and now the time is 5:10 p.m. Okay. So from 12 noon to 5:10 p.m., what is the angle made by the hour hand? Okay, just try to understand the movement of the hour hand. First, it would have moved from 12 p.m. to 5 p.m. Right? Guys, I need your responses. Um, First, the hour hand would have moved from 12 p.m. to 5 p.m. Right? So from 12 p.m. to 5 p.m., it would have covered how many degrees? It would have covered 30 into 5, 150 degrees, right? And now, since the time is not exactly 5 p.m., the time is 5:10. So because of this 10 minutes, there will be certain movement, some movement in the hour hand, right? There will be some movement in the hour hand. Yes or no? Because of this 10 minutes, there will be some movement for in the hour hand because the time is 5:10. If the time was exactly 5 o'clock, then the hour hand will be pointing towards the number 5, exactly in the middle of the number 5. But since the time is 5:10, so the hour hand will be somewhere in between 5 and 6, right? In the clock, the position of the hour hand will be somewhere between 5 and 6. So for this 10 minutes, you need to think what is the extra degree rotated by the hour hand. Now you know that the hour hand, it moves by half degrees. Half degrees in 1 minute. Where is the information? This is the information, guys. Speed of an hour hand is half degrees per minute. So in this 10 minutes, it would have covered additional 10 into half, 5 minutes, right? So now the answer becomes 5 plus 150, 155 degrees. So the answer will be option C. Okay. Simple logic. Because of this 10 minutes, there will be certain movement in the position of the hour hand. And what will be the movement? It will rotate by 10 into half, 5 degrees. So 150 degrees when the clock moves from 12 noon to 5 p.m. and 5 degrees when the clock moved from, when the hour hand moved from 5 p.m. to 5:10 p.m. So 150 plus 5, 155 degrees will be the final answer. Okay. Now, or the other way you could have done is you could have tried to convert 5 hours 10 minutes into hours, right? So this will give you 31 by 6 hours. So 31 by 6 into 30 degrees will again give you the answer. Okay. They have converted in terms, in terms of proper hours. Okay. How did they do this? They converted 10 minutes in hours. So this, it becomes 10 by 60, 1 by 6. So the fraction becomes 5 1 by 6. And when you convert this 5 1 by 6 to a proper fraction, it becomes 31 by 6. Okay. So now the next concept. Now this is important, guys, because what I have seen is mostly you get like the most basic question is comes from this particular concept, concept number 2. Now concept number 2 is simply based on the angle between the hour hand and the minute hand. at some particular time. Okay, let's say the time is right now the time is around, let's say 6:20. Okay, so what is the angle between the hour hand and the minute hand when the time is 6:20 p.m.? Okay, so you get this type of questions based on this concept. So there are like you can try to use this data and solve this question. You can try to use speed of an hour hand is half degrees per minute and speed of a minute hand is 6 degrees per minute. You can use this data and you can get the answer, but there is shortcut to find the angle between the hour hand and the minute hand. The formula is in front of your screen now. The formula is theta. Theta is the angle between the two hands, is equal to 11 by 2 m minus 30h, where m is minutes and h is hours. Like let's say if I give you 6:20, if the time is 6 hours 20 minutes, so in place of h you will put 6 and in place of m you will put 20. And now you can see these two lines. In mathematics we call them modulus. Okay, the significance of modulus is that the output of this value will always be positive. So let's say the value of 11 by 2m minus 30h, the value inside the modulus comes out to be negative, let's say minus 7. Okay, so the output will be plus 7. That is the only significance of this modulus. Okay, the output will not be negative, the output will be only positive. So let's say if you are performing the calculations inside the modulus and it is coming out to be plus 7, so the output will also be plus 7. But if the value inside the modulus is coming out to be minus 7, so when you remove the modulus it will become plus 7. Ultimately you just need to keep a positive value out here. Okay, so guys, uh, so this is the simple formula to find out the angle between the hour hand and the minute hand. Okay, because whenever they'll give you a time, the time will be in the form of h is to m. H is to m, where h will represent the hour value and m will represent the minute value. So you just need to put the values in this formula and you will get the answer. Clear? So quickly try to solve this question. What is the angle between the hour hand and the minute hand at 7:20? Okay, time is 7:20 and use this formula. Time is 7:20. Hmm. 6 people have responded till now. For those who are finding it difficult, here's the formula for you. Simply put the value of h and m. You will get the answer. Simply put the value of h and m. So the value of h is 7 because the time is 7:20 and the value of m will be 20. So when you put the value of h and m over here, it becomes 110 minus 210. So inside the modulus you get minus 100. But when you remove the modulus, it becomes plus 100. So the answer will be yes. Inside the modulus, when you perform the calculation, it will come out as minus 100. But outside the modulus, it will be plus 100. So the answer will be option B. Okay. I hope this is clear. Just try out this question. It's exactly similar as of the previous one. Pervez, it's not possible that you'll get a different answer. See, okay, guys, everyone, just try to listen to the normal approach. What would have been the normal approach? Okay, so the time was what? 7:20. Now, let's try to calculate the angle covered by the hour hand separately and the angle covered by the minute hand separately. Okay, now what is the minute? Okay, everyone, can you tell me that when the time is 7:20, what is the angle covered by the minute hand? Guys, when the time is 7:20, can you tell me what is the angle covered by the minute hand? When the time is 7:20, what is the angle covered by the minute hand? 120 degrees, right? Because in 1 minute it covers 6 degrees. So in these 20 minutes, it would have covered 20 into 6, 120 degrees. Great. So this is the value, this is the angle covered by the minute hand. Now, can you tell me that when the time is 7:20, what is the angle covered by the hour hand? If you remember, just a question back we solved, we did this question, right? We did this question where you found the angle covered by the hour hand. So similarly, when the time is 7:20, can you tell me what is the angle covered by the hour hand?